Hi everyone. So this will be our lecture 28. For this one, we're going to focus on the evaluation of projects, the concept of it, and then we're going to talk about how do we do the evaluations, what metrics we're going to use, and we're going to focus on single project evaluation for this time and give a few examples. And for next lecture, we're going to focus on the examples the calculations and examples for multiple project evaluation. So but before we get started, I want to first make sure you understand the last thing we talk about last time. We gave the definition and the calculation, but didn't give the equation. So I added here, which is the effective rate basically can be calculated like this. And in this equation, you can see R is a nominal annual interest rate usually, right? Let's say the bank will tell you for the next, for each year, the interest rate will be 12%, but it will compounded monthly, right? So in this case, 12% is nominal rate, right? But it's the real rate, the effective rate, interest rate, is actually different. And how we calculate is that use R divided by M, which is the number of compounding periods per year. If it's monthly, then M equals to 12, right? If it's compounded quarterly, then M equals to 4, right? So that's how we calculate. And then we put M here, then we powered by M minus 1. That gives us the result. And for sure, this number, you can try to calculate this, but this number is always bigger than R. This number, whichever you calculate here, is always bigger than R, the nominal interest rate. So that's actually also a way to verify after your calculation to verify what you calculated is correct. If this number, i.e. the effective interest rate is lower than R, then there is some mistake. So you want to go back and double check on your calculation, okay? And here's actually one of the charts to do the comparison. We already showed that this can be quite different, but in this case, you can see that if it's the nominal rate, this is nominal rate, right, for each year. If it's compounded annually, these two rates are the same. But if compounded semi-annually, so every 6 months, then it's going to increase to this much, right? You see this is bigger than the number we have before. If compounded quarterly, even bigger, monthly, even bigger, daily, even bigger, right? So it's keep increasing. The more frequent you compounding your interest, the effective rate will be higher, which makes sense, right? Because you are actually charging interest on the interest you accrued before, right? Whenever there's some more interest, if you can charge more interest on that, of course, the effective rate will increase. Right? So that's the effective rates and how it's different from nominal rates. So we're going to dive into the evaluations of projects. There are a few ways to understand the how do we evaluate a project, right? Many times we use the those present words, the future words or future value or annual words. That's what we learned before, right? And we can use this to find out the minimum attractive rate of return, which is MARR. What is minimum attractive rate of return? We're going to talk a little bit more later, but we can use these to find out the minimum attractive rate, right? Then use the internal rate of return and external rate of return, IRR and ERR respectively. We use those to find out exactly what will be the interest rate and compare to our MARR to find out if this, to compare these two rates, we're going to know, well, if this is attractive or not, right? If this project is attractive or not, and among a few projects, which one is the best choice? Right? That's basically the concept. And you can see that either way, we need to figure out MARR first. Minimum attractive rate of return, the MARR, is just an interest rate to convert cash flows into equivalent worth at some point or points in time. Just like the other interest rate or return rate, it's the same concept. We use that to convert our money from one point to another, from another point back, right? But what it does, let's look at the last one first. What it does is basically how we determine MARR is to consider an opportunity cost. Is considered opportunity cost. That's what MARR do. That is what MARR do. What does it mean? So minimum attractive rate of return, just by the name, right? It means this rate has to be this big to be attractive. If it doesn't achieve this rate of return, it's not attractive at all. That's what it means. Meaning that if you have some money, you have $1,000, you want to see, and you're going to invest it for 1 year, right? You want to see it to grow by a certain percentage to make it interesting to you, to make it attractive to you. That's what it means. Put it another way, right? Let's say you have $1,000. Now, if you put this $1,000 in a high yield bank account, right? That's probably is the safest investment opportunity or option you have. $1,000 put into a high yield bank saving account, not going to touch it for 1 year. Some bank may offer you 2% of interest, right? Your money going to grow 2%. Your money going to grow 2%. Now, a friend come to you saying, okay, I'm going to have a startup. Now I'm short of $1,000. I heard you have some in your pocket. Can I borrow that? And I'm going to give you a certain amount payback after this year. Now you're going to think about it, right? You're going to ask, what question you're going to ask first? You're going to ask how much money you're going to pay me back in 1 year. That's the first question you're going to ask. Because if you put in a bank and that have 2% of interest rate, you're going to get $1,020 next year, right? Now this friend tell you, okay, I think I can get you another 50 cents. You're going to say, forget about it. Go away, right? That's so small, so far away from $20 you're going to get. A friend might say, I'm going to give you $1,015. I'm going to say, no, still not attractive enough, right? Then the friend will say, if the friend is saying, I think I'm going to give you $1,030. Okay, that sounds interesting now. That starts to be a little bit attractive to you now, right? Because it's finally higher than the MARR you are expecting from the other opportunity. So that's basically what it means, right? Sometimes it can work as the opposite way. By that I mean, let's say I have a house and I have a 30-year mortgage, right? I have a 30-year mortgage. The mortgage, the interest rate on the mortgage is about 4%. It's about 4%. So that's occurring, right? So I need to pay for that interest rate. If, let's say I make some money, I feed my family, I buy all the needed toys, princess dresses my daughters want, and now all the rest of money I have, I need to think about it now, right? Should I put all this money to pay for the mortgage? Because if I pay my mortgage down to the last penny I have, I'm going to save 4% of interest. I'm going to save 4% of interest, right? Now, another friend going to come and tell me, hey, Ryan, the stock market is doing very well now. Not now, right? But hypothetically, it's doing very well now. You should put your money into the stock market. Then first question I'm going to ask, yes, how much do you think I'm going to make? What interest I'm going to make from the stock market? He's saying, roughly 3.5%, very high. Like, nah, I'm going to pass. Because if I pay my mortgage, I'm going to save for 4%. Why should I buy stocks, right? But if the friend is saying, it's about 7% based on the 30-year period. For the last 30 years, the S&P 500 growed 7% or 8% every year on average. I'm thinking, yeah, that sounds better, right? Even though I need to pay 4% of mortgage interest, but I'm gaining more from investing in stocks, right? Also, see the difference here for me is that I have a few choices. I can put my money in banks, that's 2%. I can pay down my mortgage, that's 4%, right? Or I can put in the stock market, maybe that's 7%. Now I'm going to think, okay, which one is the best? If I investigate to, let's say I'm thinking about stock market, right? Then I need to decide my minimum attractive rate of return, my MARR. For me, it's not 2% anymore because I do have another pretty safe, guaranteed interest rate, opportunity cost, right? Which is my mortgage. If I pay down my mortgage, I'm gaining 4%, right? So if I do decide to invest in the stock market, my opportunity cost is 4% to pay back my mortgage. Right? So that's what it means by minimum attractive rate. To decide on the minimum attractive rate, obviously, is based on multiple things, right? It's based on multiple things. It can be based on the amount, the source, and the cost of money available for investment, how much money I really have for investment, right? It can be based on number and the purpose of good projects available for investment, right? So if I have two choices, then I'm thinking, okay, what will be my gain? What will be my gain, right? I have 2% and 4%, then 4% is my minimum attractive rate. I need to beat that. But for you guys, if you don't, you didn't buy a house, you don't have mortgage, then you maybe the high yield bank account is your only choice, your only available opportunity cost, only available investment opportunities, right? Then you need to, then your minimum attractive rate could be 2%, right? Maybe some of you have a really good friend who is really smart, already have 10 startups. He come to you and say, look at this. I have 10 startups. One interest rate is 5%. The other is 6%. The other is 7.5%. The other is 3%. All of this, pick one. I'll let you in. Now you need to think, wow, there's so many opportunities. Which one should I choose? Which one has the best? Which one is the best, right? It's also based on amount of perceived risk, right? We haven't talked about that yet, but let's say you can put your money in a bank and that give you 2% of interest. You can also investigate in a startup that give you 2.5% of interest. But we all know startup is very risky, right? So when you think about that, okay, that's what we calculated, but the risk is there. It's hard to quantify the risk here, but we all know startups have a really high risk. When you factor that in, you may think, well, 2% is lower than 2.5, but since 90 or 95% of startup fail, I think I'm just going to go with a high yield saving account, right? That's obviously depend there as well. To decide on the MARR is also depends on the type of organization, right? If you are public, it's easier for, or you are private, it's definitely have different minimum attractive rate of returning, right? For private, we're looking for best profit, the highest profit, but for public, it's more about the well-being of the public. In that case, my MARR could be different. The calculation could be different, right? But either way, MARR should be chosen to maximize the economic well-being of the organization. Should be chosen to maximize the economic well-being of the organization, right? So that's the definition of MARR. Once you have the MARR, right, then now you are searching for a project which basically we are trying to find one that's interest rate using funding equivalent values should be greater than or equal to the average cost of capital. So whatever project you decide to choose is need to be at least as high as other investment opportunities. Remember the 10 startups your friends provide you. You want to choose the one with the highest investment opportunity. Or if two, both are 20% of return, that's the highest, then you can pick one from that, right? So at least as high as other investment opportunity. The discount rate will equal the minimum accepted rate of return. So basically equal to the MARR. The choice you make to decide the interest rate is very important in evaluating a project. It's very important in evaluating a project. And it actually can play different roles in different situations, right? Usually, if you have a relatively or very low rates, that usually favor large projects with distance benefit. Large project with distance benefits, right? This could be, let's say, a public-private partnership to build a highway, right? Let's say the government allow your company to build the highway. You need to take quite a few years to finish the project. Then you can start to charge the tolls for all the passing vehicles and collect it, right? The rates usually are not really high, right? But if your MARR is relatively low, and that's going to help make you to decide, well, even the payment is not that high for long term, because it's usually a 30 or 50 years of operation. Long term, you're going to make steady stream of money coming into your organization, right? So using this kind of very low rates often lead organization to undertake massive projects while ignoring current needs, right? Then in the opposite situation, very high rates favor staged investments with quick payback. Using very high rates can prevent you from undertaking large infrastructure investments, like what we said before, right? If it takes 30 years or 50 years to make all the money, that's probably not for you. Probably not for your project, if you your organization, if you have very high rates, right? You want a faster return, you want to make a lot of money very soon. It's different, right? Different company operates differently. There are companies, investing in the large projects, infrastructure projects like the like the example we use, right? They are collecting tolls all the time. So yeah, in this COVID-19 situation, this public crisis, not many people are traveling on the road. So for this for this month or this 6 month, they are not collecting a lot of toll. But after that, well, people start coming back. I start getting collecting tolls again, right? So in a long run, it's not going to impact that much. But for a small company, there are companies actually, using this different opportunities to make money, right? To investigate into the stock market, actually buying the using the dip of the stock market to make a lot of money, and they take a lot of risk, but they want the money to pay back very fast, right? I see a person who during this uh, dip of stock market turned 2.7 no sorry 27 million into 2 billion. I think I see a story like that. There are people doing those kind of things, right? In that case, of course, you are favoring they are favoring a high rate, and also they suffering big risk as well, right? So I hope you understand the concept here. Now, using that, that's how we do single project evaluation, right? Project evaluation. The concept is something like this, right? Using the present worth method. So we want to make sure that equivalent worth of all cash flows relative to the present as a base. We use all the cash flows and turn them into present. All cash inflows and outflows discounted to present at an interest. And that interest rate usually use MARR. We use the MARR, right? Present worth is a measure of how much money can be afforded for investment in excess of cost. So we put all the money at time 0, we can find out how much money we can afford to for the investment. Usually a positive, a present worth or present value for an investment project means that a project is acceptable because it satisfies MARR. It's higher than MARR means it's attractive, and then you can do the investment, right? So this is basically how we do it. We convert everything and to the present value, and we find the result, right? We find the result. Now, here's one example. Right? So a piece of new equipment has been proposed by engineers to improve the productivity of a construction company. The investment cost is $25,000, and the salvage value is $5,000 at the end of 5 years. So let's say you sell the equipment at the end of 5 years, that give you $5,000. Because you bought the equipment, right, the productivity will increase by 8,000 per year. Let's assume your MARR equals to 20%. Again, here MARR means at least it need to be this high, right? At least need to be this high. This means if you don't do this, you bring the $25,000 to investigate, to maybe open up another small factory or invest in new technology that will give you 20% of interest rate. This is annually, right? Now you want to say that you want to make sure this is higher than that, right? This is higher than that. So the question is this a sound proposal or this is not? This is sound proposal or not? Now, this table here, all the equations we need from before are listed. So now think about it. I'll give you 2 minutes, maybe pause the video, take 2 minutes to calculate this, and let's see what will be your result. Okay, really the calculation is not different at all from what we did before, right? Really, if you think about it, before we have I, now we're just using MARR, right? We are basically just using that. So still, the first thing we do is draw the cash flow. It's already given at the beginning, but if it didn't, first thing you want to do is draw the cash flow, right? Going down is money out, going in is money gained. Cost, revenue, right? Okay. The cost at the year 0 is $25,000. And then for each year, you are making $8,000. But at the end of year 5, you sell the equipment, you're going to get another $5,000. So all this together, that's how much money. That's the cash flow. That's the cash flow, right? So with this, basically, remember the example we're talking about present worth. We're using the PW method, right? So we convert all the cash flow back to the present. And I basically here I showed this, right? You can use all the formula. There's multiple ways to do it, right? You can take this $5,000 just as a future value and use this function, right? Use the future value to find a present value for this $5,000, and then treat all the other $8,000 per year as another part of annuity. So you have A, you want to find P, you use this equation, right? You can find P. All those things work. But here I just I used Excel. I use Excel, but one by one, right? I convert each number, each year's value back to the present value. This is year 1. We're making $8,000, and what I did is use this divided by 1.2, which is 1 plus MARR. 1 plus 20% equals to 1.2. And this give me this, right? $8,000 for year 2, same thing, $8,000. I divided by 1.2 square, give me this. This is $8,000 for year 3 divided by 1.2 cube, right? Give me this. So on and so forth, so on and so forth. I can find out. I convert all the money back to present value and add them all together. So this is my present value for all the revenues. It's $25,934.3. Right? That's that much. And then my investment was negative $25,000. So the value here is negative $25,000, right? This minus this, or this two add together, this is positive, this is negative, give me $900. So this means all the income, all this revenue, when I use MARR equals 20%, which is honestly pretty high, right? Even with 20%, when I do the calculation, it's exceed the $25,000 I paid at the beginning. I invested, right? It's still giving me a positive value, meaning I did the right thing. So this is actually acceptable. Right? Obviously, we can also do this with Excel. And for Excel, what you want to do, we didn't talk about net present value last time, but what you can do is that you can use a function. So first you want to convert your cash flow into this format in Excel. So what you have is basically something like this, right? You have year, inflow, outflow, net value, and then year one, the outflow, there's no inflow, outflow is this much, right? Year one to year four, it's always $8,000. Year five, it's jumped to $13,000. And then this is outflow, right? The net is basically, you can see it's just the sum of inflow and outflow. So basically, this equals to this plus this. And I'm just going to drag down its sum for all those. This is what it gives you, right? So then you can use the net present value function to calculate this. To do that, go to financial and click on NPV. That help you give you some cells to input your value, right? The rate is 0.2. The values, remember when you do the net present value, select from year one. Don't include year zero. Select year one, right? So I select $8,000 to $13,000, and you can see the result is $25,934, right? That's the value here. Then obviously your present worth will be this plus this, give you $900. Give you $900, right? If, like I said, when you use NPV, you want to select from year one to year five. That will convert everything to year zero. All right. So that's how we use Excel to do this. And then there's obviously, if we can do its present value, we can do the future value, future worth, right? Future worth is based on the equivalent worth of all cash inflows and outflows at the end of the planning horizon. In an interest rate, that is generally MARR. Same thing. Again, all the calculation is the same like what we did before, from present value to future value. Only thing is that if FW, the future worth, is bigger than zero, then we could investigate in the project. Otherwise, no, right? The decision based on all of this, both of these are the same. So for the same cash flow, same in, same out, you convert to present value. If it's bigger than zero, then after you convert them to future worth, it should be bigger or equal to zero as well. Bigger than zero as well, right? No way when you convert to present value, it's smaller than zero. Then after you convert to future worth, it's bigger than zero. No way that is going to happen. It's the number going to be a little bit different, but positive will stay positive, negative will stay negative, right? So the decision you're going to make will be exactly the same. Now, same example. Right. Take 2 minutes to calculate what will be the future present. All right. So the calculation is exactly the same. I still did it this way. Same cash flow, right? I convert each one into future value, each row into its future value. Add them all together. The future value from the investment, from the revenue, will be $64,532.8. The investment will be negative $62,208. So this one is bigger than this one. Then I added these two together. The future worth will be 2,000 something. So it is positive. It's bigger than 0, so the project is economically sound. The project is economically sound, right? So look at this. We made the same decision, right? Same cash flow, we achieved the same decision. Present value is this. It's positive, so we think it's a sound proposal. Future value, same thing, it's positive, we think it's a sound proposal. Now my question is, what is the present value of 2,324? So basically this number, what is its present value? Think a little bit about it. You probably already suspected, yes, this number, when we convert it to present value, it's this one, right? It must be this one. So after you do the same conversion based on the MARR, you convert this present value into future value, they are exactly the same. They have to be exactly the same, right? So that's future worth method. Then there's also the annual worth method. Right? The annual worth method is an equal annual series of dollar amount over a standard period, equivalent to the cash inflows and outflows at an interest rate that is generally equal to MARR. So annual worth is an annual equivalent to revenues minus the annual equivalent expenses. So the revenue is R, the expense is E, and also less the annual equivalent capital recovery. Right? So AW should be R minus E minus CR based on the percentage of I, the interest rate, right? CR here is really equivalent uniform annual cost of the capital invested. Say that again, it's equivalent uniform annual cost of the capital invested. And this chart actually, so it includes the initial or other investments and the salvage value, right? So this basically shows what it looks like, right? What you have is I, the investment at the beginning. Then see from each year you have some revenue, and then you have some expense, right? Again, year 2 you have some revenue, some expense, on year K, so on and so forth. Then at the end you have some expense as well. You might have some revenue, but you also have the salvage value for the equipment or for your investment. Think about the machine, which we said before you bought, right? Now you sold it, or you changed it to just to sell as a piece of, I don't know, garbage, and then what will be that value, right? That's the salvage value. So we basically want to convert all of this into an annuity. And then we want to make sure the annuity is bigger than 0. Only if the annual worth method, is bigger or equal to 0, the present is economically attractive. The project is economically attractive. So it's really not that different from what we have before. once you have any present value, you can convert that to A. And if you have any future value, you can convert that to A as well, right? All these kind of things, except replacing I with the MARR, all the other things stay the same. The functions stay the same. We already did the examples on this, so you can easily convert any P or any F to A, right? That's not a problem at all. Okay, let's go back to the example we used before, right? Same example here. This is our cash flow, nothing changed. This is our cash flow, nothing changed, right? Now, what we want to do is that we want to use our annual worth method to calculate if this is a sound project or not, if this is a sound proposal or not, right? I want to convert everything to annuity. The funny thing is, the funny thing is that we already have an annuity here, right? We have different part. We have annuity, annual income. Remember what we want to find is annual revenue, the annual expense, then how the investment averaged out annually, and then the salvage value annually averaged out annually, right? So we already have this 8,000 per year. We already have this, right? This is already on each year. We don't want year one. We don't want year zero. We want from year one to year n. We already have this part. This part doesn't need to be changed at all. The only thing we need to do is convert this to an annuity, right? We have a future value. We need to convert this to annuity. We have a present value we need to convert to annuity, and then we have a future value to convert it to annuity, right? So for a present value, so basically we have a present value, we want to change it to an A, and then the equation we're going to use is this, right? We used this before. The P is negative 25,000. Then we input I and N. We can calculate this, going to give us an annuity of negative $8,359.5. So if we convert this to a cash flow on each year from year 1 to year 5, each year it's going to be negative $8,359.5, right? So basically in here we're going to, like I showed, I'm going to draw another flow, converting here, remove this, but it become an outflow of negative this amount each year. And that's that part. Then we also have this part, right? This is positive, this is the inflow, $5,000, and it's in the future, right? We convert that to an annuity, CRS. That's $5,000 multiplied by this part. Different from this because this is future, right? For this part. Then it gives us $6,701. $671, right? So again, I basically remove this. Now I can remove this and add a small bar upward each year, and that value is equals to $671, right? Now I basically have three annuity cash flow. Then for each year, I have the original $8,000 income. I have $8,359.5 outcome, and then I have $671.0 income again, positive. So I add them together annually. The cash flow is $312.4. That's the converted total annual uniform series. Total annual uniform series. And so basically now it's become year 1, year 2, year 3, year 4, year 5. Each year you have $312.4. If you convert that to present value, that's going to be $934 something, right? If you convert all this into future, that's going to be 3,200 something, I believe. The one we calculated before. No, so $2,324 something. That's what we calculated before, right? They're all the same. They are all the same. And you can see that the before, based on present worth or future worth, the money, the amount we get, the decision we make are positive. And here, the decision we're going to make is positive as well. This is a sound investment, sound proposal. Okay, I hope that makes sense. Last example, show you, it is this one. Okay, I'll give you a few minutes. You see a dog, actually a bunch of dogs here, right? Based on this, you can calculate, try to calculate this, right? The example here is an investment company is considering building a 25-unit apartment complex in growing town. It is estimated that there will be on average a 90% of occupancy each year. What is the minimum monthly rent that should be charged if the MARR is 12% annually, right? So here are some investment. You need to buy the land, $500K. You need to build the building, it's $2.25 million. Study period is 20 years. Right? Rent per unit per month, that's what we need to find out. Maintenance per month per rented unit, 350. Property tax and insurance per year will be the 10% of total initial investment. So based on all this, let's try a bit. Let's try what will be the result. So again, first, draw the cash flow. Based on the cash flow, think about what would be your strategy to calculate this, and then we can work on it together. All right, so I draw this cash flow, right? I draw this cash flow. It basically has 3 parts. The initial investment is $500K plus $2.25 million. So that's why I get $2.75 million. That's your investment at the beginning, right? Then you have, we need to pay for each year, we have some cost as well. The cost, one part is a property tax, which is 10% multiplied by the initial cost, so 2.75 million multiplied by 10%. Then there's also other cost, which is the maintenance per month per rented unit. So $330 for maintenance, $350, right? And remember that's per month, so we need to multiply by 12, right? We need to multiply by 12. And because there are 25 units, then we need to add, multiply by the 12, multiplied by 25. So 350 multiplied by 12 months multiplied by 25 units, right? That's how much money we're going to pay for maintenance. That's our expenditures. our expenditures. There obviously need to have some income, right? The income is the inflow is rent, which is what we need to decide for each unit, right? Which is A, multiplied by 25 units, but we are thinking only 90% of this unit going to be rented out, so multiplied by 0.9, and then multiplied by 12 months. Per year, there's 12 months rent to charge, right? So that's basically what we're trying to do. And now we need to find A, right? We need to find A. Because A is unknown, to convert all the annuity to present or future value, it's a little bit tricky. You can do it, no problem. It's just a little bit harder, a little bit complicated, right? So our strategy is really just to convert this initial amount to annuity. Right? So we want to convert this to annuity. And we already showed this, how to do this, right? We're trying to find A, which is PMT function in Excel. That's what I did. So the rate is 0.12. Number of period is 20 years. Present value is $2 million and $2.75 million. And then when I put it, it gives me per year's cost is the cost is actually negative 368,166 $0.6 something, $65 something, right? So basically this is cost, right? This is negative, this is cost. So why convert this to annuity, convert the initial investment to annuity, this is our cost. So this is inflow, this is cost. We want this one at least to be this big so we can break even. It's back to break even, right? So this part need to be equal to this part. And we add this together and divide by this, all this number. Then we find that for each month, we want to charge $2,770.99. $2,770.99. Right, that's going to our rent per unit. I hope this makes sense. This is all I'm going to cover today. We're going to talk about the internal rate of return, and we're going to talk about multiple projects evaluation next time.